for listening us. Today I will try to explain and present the main results of the FirESmart project. So first of all, what is FirESmart and why we need FirESmart management? Well, the extreme wildfires are becoming more frequent, not only in Europe but also in many other regions across the world. And this is, in the case of Iberian Peninsula, clearly a consequence of the land abandonment processes that already start in the second part of the last century. So the rural exodus has gradually increased the field of vegetation accumulation in our landscapes, and also has increased the connectivity of these field loads. At the same time, on a global scale, we are suffering an increase in temperatures, an increase in the drought events due to climate warming. So the combination of those factors have increased the flammability of our landscapes and also the probability of suffering large and high-intensity fires. So these extreme wildfires has tremendous impacts on our ecosystems and also on our society. It's a challenge that we need to address, and we need to do this in a very sustainable way. And this problem, which is a long-standing problem, is even worse. And we are not able to respond as we should to this societal challenge. But why? Well, we must acknowledge the role of fire as ecological process in Mediterranean ecosystems. This is one thing. We also must acknowledge the ancestral use of fire as a tool to manage landscapes. So we need to change the fire suppression paradigm. So nowadays, the authorities are there are investments on fire suppression, and prevention is almost neglected. And this is paradoxically leading to even more flammable landscapes, because we are suppressing our fires. We are removing fire, which is an ecological process essential to understand our landscape and fire regimes, and we are removing these processes from our landscape and ecosystems. So we are contributing to this accumulation of fuel and the continuity of vegetation at very large scales under extreme hot and dry conditions. This inevitable leads to situations that firefighters cannot deal with. So what are proposing here with the FirESmart project? Well, basically we are trying to find solutions, and what is important is that we are trying to look at nature-based solutions, sustainable solutions. So we want to reduce the wildfire hazard, that risk of suffering large wildfires. But at the same time, we want to ensure the biodiversity conservation, especially in protected areas, and also the delivery of different or multiple ecosystem services. So the benefits that our ecosystems are providing to human well-being. This is something that is on the root of the problem. We have different factors from the socioeconomic dimension of the problem, and we have also ecological factors, as I already mentioned. So we need to integrate both dimensions to address this challenge, to solve or at least minimize this increasing risk of suffering extreme wildfire events. And this is our main goal. So this project started in 2019 and is funded by the Portuguese government in response to the large wildfires that took place in Portugal in 2017 with dramatic consequences. So we are taking this very seriously. We are trying, we are doing our best to try to contribute and help decision making and also policy making to take the right decisions at the right time. To address those questions, we focus on two particular study areas. The Biosphere Reserve area Suez, which is situated between Spain and Portugal, more specifically in the north of Portugal and Galicia, and the Meseta Iberica. Both are transboundary, which is an important component. We need coordination, not only at the fire suppression level, but also at the landscape management level. And they are also quite representative of a mountainous rural area in Southern Europe. We have unique cultural, socioeconomic, and natural values. But also, we have fires, and we have suffering from the difficulties to live in these remote and marginal areas. So it's not easy for local communities to stay there and be productive and be able to survive under quite dramatic and hard conditions. So what is the approach? How we try to get these objectives? Well, first of all, we have designed a variety of scenarios, policy and management scenarios, to try to see, okay, what if we implement this kind of management or policy in our landscapes? What would be the consequence on fire regime? And what would be the consequence on biodiversity and ecosystem services? So it's a quite interesting strategic foresight exercise where we involve local stakeholders, which are an essential component in this type of exercises. And we also had to develop quite sophisticated models for being able to, implement the processes that we want to consider and what are the main drivers in our regions, and also the land use policies that we could implement in the near future. This is not an easy task. It's quite challenging. There are technology to do that, but still a lot of uncertainty that we must acknowledge. Anyway, it has been demonstrated to be a very interesting approach and contribute and support in some way decision making. So the first step was, okay, let's see what is the opinion and what is the perspective of those stakeholders. But considering different sectors, we need forest actors, civil protection, government, local communities, nature conservation agencies, and research. So we sent a questionnaire with different questions in order to see what would be the perspective of stakeholders about the capacity of our firefighting systems to deal with these large fires, what are the main causes, what they expect from the future. So what could be the best strategy to deal with these large fires. And it was quite interesting that we found a quite general agreement among stakeholders across sectors and both study areas. So they basically state that fire must be managed and support fire prevention rather than fire exclusion policies. They also acknowledge the role of rural abandonment as one of the main causes of these large wildfires, and they also expect that the trend and the number of these high-intensity fires will be even larger in the future. So regarding the field management strategies, they have set almost all of the strategies that we propose, which are, for instance, increasing field breaks, changing forest composition to increase fire resistance woodlands, using prescribed burning, mechanical treatments, with the only exception of the chemical treatments that were not well seen by the stakeholders. And they also give us a feedback in terms of what would be the benefits of this fire management strategy on a series of ecosystem services. So it was really nice to have this feedback right at the beginning of the project in order to ensure that we are designing and considering the most plausible and feasible management scenarios in our region. As I said, we need a tool to implement these processes and policies in our models, implement these scenarios and see what would be the response of the different components that we want to assess. Basically, we develop what is called the remains model. Each are mathematical models that integrate fire ignition, spread, and also extinction. We have two different fire suppression strategies that the model is able to mimic in some way. We have also an ignition probability layer that is updated at any time step of the model. We have a vegetation dynamic model to simulate natural subsection and post-fire regeneration. And then this fire subsectional model is combined with a land use change model for being able to implement land use change policies. So it's quite complex. It's not easy to implement. It's very hungry model in terms of data that we need to calibrate the model, but obviously it's a very powerful tool to implement those scenarios and see what would be the consequence of our landscapes, and in combination with other modeling approaches also on biodiversity and ecosystem services. And that's precisely what we try to evaluate in one of the first studies. In this, we focus in the Jerez Biosphere Reserve, and we consider some of the scenarios that we designed at the beginning of the project, what could be representing the land abandonment trends. Then we envisage a contrasting scenario where with policies promoting agricultural and livestock activities, so promoting or increasing the farmland areas, which in our region, which is a protected area, are associated with high levels of biodiversity. In Europe, we call this type of farmlands high native value farmlands. And we also consider a combination of high native value farmlands with a large-scale conversion from evergreen, or let's say forest plantations with fast-growing tree species to a more resistance and resilience tree species, basically native oak woodlands. Okay, what we found, or our simulations is trying to suggest, is that if we increase gradually the amount of farmland areas in this region, we have creating further fire suppression opportunities. So the area that will be able to suppress with the same investment in fire suppression, that's an important point, with the same resource, just changing the composition of our landscape in favor of cropland areas, we have an increase, especially in the medium and long term. So it takes some time to get these good results. We get these opportunities for firefighters. Surprisingly, the conversion to more forest resilient, fire resilient stands was not so good in terms of fire suppression. This is probably because our area is dominated by the shrubland. It's mostly 70% of different type of shrubland, grasslands, rocky areas, and the forest is representing less than 20%. Anyway, the combination of both scenarios could be creating these fire suppression opportunities because of the farmland areas. And in terms of, of carbon sequestration, which is basically our proxy or our measure to see climate regulation services, is precisely the FirESmart conversion, which is increasing or is expected to increase carbon sequestration rate over the next decades. In second place would be the business as usual, which is the land abandon trends, would be also positive because we have more forests on the landscape, and this new forest is storing and capturing the carbon dioxide. Still, the combination of high net value farmlands with FirESmart could be able to keep constant more or less the climate regulation capacity of our landscapes. And what about biodiversity? Well, this is very clear and is a tremendous example of what is a win-win situation. What happened in our region is that under high native value farmland say policies, we have an increase in the availability of habitat for many vertebrate species. We model more than 100 vertebrate species under these scenarios, and it was clear that the trend is positive when increasing farmland areas. And it makes sense because we know from different studies all across Europe that the species that are suffering the most are the grassland species and farmland species because of this, well, land abandon trends in these marginal mountain areas, but also the intensification of agriculture in more profitable regions. So at the end, these species are suffering, and our scenarios are saying that that would be a very good option in terms of biodiversity. Okay, but what happens if the Common Agricultural and the upcoming revisions still fails at reversing these rural abandonment trends? Could be land abandonment or rewilding an option for those areas, especially considering the side effects on fire region, because we are increasing flammability of our landscapes? Could be a reasonable option in these areas? Well, we test these scenarios where we assume the land abandon trend in our landscapes, but in that case modulated by different levels of fire suppression. So at the end we have more fire or less fire in our landscapes in a context of rewilding or land abandonment, and in a context of high net value farmland systems. What we found is, again, high native value firelands are the best option for more than 70% of species, but there are a quite interesting number of species and endemic and threatening species that could be favored by these rewilding initiatives, especially those associated with forest. And also, and it's something that, in my opinion, is very interesting, is that around 30% of species in our region could be benefited by open habitats created by fire. So 34 species would experience an increase in the availability of their habitats with low fire suppression systems, so allowing some fires burn. So at the end, if we acknowledge the limitations of the common agricultural policies to face these trends in these marginal areas, what we can see is that, okay, we can get some benefits for biodiversity with rewilding initiatives, and in some way we can reduce the fire risk associated with these wilder landscapes. So we can use fire, we can try to modulate with fire suppression or try to implement prescribed burning strategies. Is something that we need to explore more in detail, but obviously that options has to be on the table, and we must consider and we must to acknowledge that fire has been playing an important role in these landscapes, and it's an critical processes that we should not exclude from our landscapes. But what about of the trade-offs in terms of costs and benefits of these strategies? Something that is critical to consider a FirESmart strategy and nature-based solution is that we need to address a specific societal challenge. In that case are the extreme wildfire events, but at the same time we need to ensure the sustainability of the local communities. We need to ensure that we are in some way creating job opportunities, and it could have a future for those communities. So what we here we combine those scenario analysis, the same that I just explained through our fire landscape modeling, with some economic tools to identify which of these policies would be best in terms of expected wildfire-related losses. And we apply a specific methodology that allows us to see that basically it could be a critical role on the FirESmart agroforestry policies to promote these solutions to the wildfire problem in these areas. And why? Because promoting extensive agriculture will provide fire suppression opportunities, generating benefits in forms of saving in fire suppression cost, as we can see here. High native value firelands and the combination with FirESmart, we have negative values, which basically is suggesting that we are saving money in fire suppression thanks to the opportunities that firearms are providing to firefighters. There is also the component of what are the impacts from economic point of view of wildfires on the different ecosystem services, which are the most important for these communities: timber production, recreation, because it's a protected area, climate regulation, but also pasture provision of the provision. It's not surprising that the benefits and also the damages or the avoided damages in provision services are almost close to zero. I mean, it's an area that is affected by land abandonment because it's difficult to implement, it's not very productive, is still and it will be still less productive in the future. So the most incomes came from timber production and from also recreation and climate regulation services. So basically, the combination of high need to value farmland policies with FirESmart conversion potentially will generate the smallest net cost to our society. So we have the lowest net suppression costs and also wildfire ecosystem damages. So the new CAP policy is actually offering an excellent opportunity to incorporate the FirESmart thinking into these new policies that will contribute to wildfire cost mitigation. So I would like to emphasize that we need some payment for ecosystem services as a governance approach to in some way reward private land owner services for the wildfire protection. So the fire regulation and fire protection services should be paid in some way. Well, it should be considered when implementing these policies. But not all is, as I said at the beginning, is a matter of the rural abandoned trends that we're suffering in Iberian Peninsula in these marginal areas. Mediterranean basin is also a hotspot of climate change, so it's especially vulnerable to climate warming, and obviously this is affecting also the status of vegetation, and in fact regional climate projections are clearly showing warmer and drier climate conditions in the future, so we are expecting also higher fire danger and longer more severe fire seasons. Even considering the Paris Agreement efforts to limit the temperature. In those conditions, the effectiveness and opportunities for wildfire suppression will be much lower, so the flammability of our landscapes are expected to be even higher. We confirm this also in the other side, in the transboundary biosphere reserve Meseta Iberica, which is one of the most, is the largest biosphere reserve in Europe. It's huge, it's almost 1 million hectares. And here our modeling simulations show that the climate change will increase the fire danger, the frequency of the let's say fire weather conditions, which are associated with large fires in our region, in terms of fire spread rate and fire line intensity. We also found that it would be not the same, and the broadleaf forest will not typically exceed the thresholds of the wildfire suppression capacity. So this is also suggesting that we need landscape level field treatments to reduce the field load and to mitigate the future impacts of climate in fire regime. Okay, and in the next studies we try to implement FirESmart strategies, but also climate smart initiatives that are under the umbrella of the new the European Green Deal. Basically, those initiatives are related to afforestation practices and wildfire initiatives, and basically these kind of management options are aiming to increase carbon sequestration, to try to mitigate climate change impact through the conversion of rangeland areas or agricultural areas into forests. But as I said before, this is also quite controversial, especially if we not consider very carefully when we are going to implement these actions and where and how. So we are trying to answer these questions in the Meseta Iberica, and we implement those scenarios. Here on the left side we can see the different trends of the landscape, and then the measurements of on the total economic damage of carbon sequestration. Obviously, climate smart scenarios are predicted or to deliver the highest rates of carbon sequestration and storage, and also to prevent more economic damages due to this reduction in the carbon emissions in comparison with the FirESmart. But still, climate smart scenarios were predicted to deliver more benefits also for some species of conservation concert, even in a higher number than in the other region, because this is still or more dominated by farmland areas. So it was especially interesting for conservation of the species. FirESmart, in contrast, is predicted to secure the availability of habitat for species that are adapted to this semi-natural and open habitat species. So this study support a more informed landscape management decision making in our region. Still, this study should be complemented with analysis on a much larger number of ecosystem services to really contribute to a ranging risk assessment for the successful implementation of nature-based solutions in this area. So what we have been doing after that study was, okay, let's try to see where are the trade-offs across different ecosystem services and biodiversity conservation of these scenarios, and let's see how we can maximize the benefits and minimize the negative impacts. So basically we used what is an optimization conservation algorithms implemented in a spatial conservation prioritization tool. We use in that case Maxang, which is software developed by researchers and institutions from Australia, which has been well applied to support this kind of conservation planning decisions. So we implement this strategy considering those scenarios that I mentioned before, and considering also that the biosphere reserve are a clear example of how an area should be sustainable, and how we can plan in the landscape in order to preserve biodiversity, and at the same time try to use or try to get services from our ecosystems. So here we are consider the present conditions, and also after doing that simulations, what would be the best way to zonificate the area under afforestation or farm return scenarios, under business as usual and agroforestry recovery scenarios. What we found basically is that the Meseta Iberica could maintain habitat for most of the species, several groups of ecosystem services. Changes in management and planning would be needed to ensure the maximal potential in terms of biodiversity conservation and ecosystem services. But basically, we identified two main management actions. The first one is an internal redesign of the zoning of the biosphere reserve, especially in the core areas. So we need a considerable expansion of these core areas to ensure and to mitigate the impact of climate change on biodiversity and to accommodate ecosystem services. And at the same time, the biosphere reserve, we need to look at different management policies, since the business as usual will lead to encroached landscapes, which will be more prone to high intensity and wildfires with more damages from ecosystems. Well, our suggestions are that we should go through a climate and climate smart policies to a more resilient landscape. Both options are good and provide some positive effects since both will help to promote multifunctional landscapes, to mitigate and adapt to climate change, and also to ensure the biodiversity under future climate conditions. But it should be probably complemented with some species-oriented management plans. So there are some species that are expected to decline, especially due to climate change, which are the main factor here, but also the land use changes. As we already mentioned, FirESmart strategies are often positive for species linked to open habitats, while these climate smart afforestation and rewilding are good for forest-dwelling species. So there is a trade-off, and in this case, both climate smart and FirESmart strategies are expected to be good for the biosphere reserve in terms of biodiversity, but we need to be it will need to be very carefully planned on the ground to avoid the potential increase in the fire intensity. So, in summary, our model simulations support that local stakeholder perspective, and also recent research about the role of agroforestry policies, the important role to promote sustainable solutions in abandoned rural landscapes. Land use policies promoting fire areas will provide fire suppression opportunities by creating open spaces that will be also positive for ensuring biodiversity conservation. So we need a large amount of cropland areas in our landscapes over the next decades to have an impact on the fire regime and to reduce the risk of fires. Here, again, we try to remark the importance of this the revision of the new CAP, and how important is the incorporation of fire regulation capacity and protection ecosystem services in the equation of common agricultural policies. These policies will be positive for biodiversity conservation, especially in this context of abandoned landscapes. In terms of climate regulation capacity and climate change mitigation, our models also predict that climate smart scenarios, rewilding or afforestation initiatives will be the most advantageous for climate. But FirESmart management also stands out as a very efficient solution for climate regulation, while also contributing to fire regulation and the transition toward more resilient landscapes. Although the FirESmart forest conversion would be beneficial for carbon sequestration, needs to be implemented within the agricultural policies to ensure the conservation of local biodiversity and effective reduction of the wildfire hazard. So we are suggesting that an integrated scenario would be the best option, and we need to again try to incorporate this FirESmart thinking into these agricultural policies from a socio-ecological and economic point of view. So if in the worst case scenario, if the new EU CAP fails and reversing rural abandoned trends, rewilding and tree planting initiatives will keep getting attention of nature-based solutions to climate change, Our simulations suggest that they are expected to be positive for many species, endemic species, endangered species, and also for climate change, but we will need to use fire to offset in some way the side effects on fire regime. We need to very carefully planning of these climate smart strategies. We will need it, as we show, for instance, in the Meseta Iberica, will be positive, but it should be in some way integrated and optimized when implemented on the ground. So there are clear trade-offs. This project is a clear example of the importance of considering and assessing the impact of different management options at the line scale level on fire regime, biodiversity conservation, and ecosystem services. We need this integrative, or let's say holistic management approach to really cope with increasing wildfire hazard in abandoned landscapes. In terms of productivity of the project, we are quite proud because the FirESmart is now coming to an end, and the outcomes has been published in very good journals, having also a great media impact. We have worked in the dissemination and knowledge transfer through different activities. We have a website, please feel free to visit. It's FirESmart WordPress, where we can find what is the team, what is the approach, what are the main outputs in terms of dissemination, in terms from more academic point of view. We have published until now 16 papers. We have also contributed with 25 communications to different national and international conferences in different countries across Europe, Portugal, Spain, Italy, France, Estonia, and even USA. We also, of course, part of our job, supervise in the context of the project different master and theses. Of course, I encourage to visit also the website and click on the video. We have, in collaboration with ScienceSheet, a company which is specialized in this kind of outreach activities. We have developed a very nice, we have created a very nice video that tried to summarize the main results of the project. So I invite you to visit the website and to see feel free to use the video for educational activities, or for your kids, or for your family. It could be really great to expand the messages and our recommendations, not only to policymakers or decision makers, but also to the overall society. We are also quite proud that at least the last report of the WWF was partially based on the results of the FirESmart project. So in the last report, they suggest the need to create more resilient landscapes, and also consider the landscape options that we have been measuring in our project. So it's great to see that we are having an impact. Please contact us if you have any questions regarding the results, regarding the methodology. Feel free to use the material that we have been producing over the project to help management, to help decision making, in order to get or try to at least minimize the impact of these wildfires events. that we are facing. Well, thanks for your